In this video, I'm going to further focus on the successive auxiliary technique. In part 1, we got our way through the first successive auxiliary that helped us produce an isometric view of this cube with the corner clipped off. I have my prop here just in case we need it, but in general, we can start to trust the drawing system and not have to rely so much on trying to see through the prop. That actually can be a lot harder as we're not really able to visualize how these transformations take place. But I will use it every once in a while to reference kind of what angles we are combining in 3D space to generate the views you'll see come out of this act of motion or tumbling that we're going to introduce into the drawing. Now, this is a lot of tracking points. It's continuing to do what we're used to in developing any projected view. If you follow them along, keep each point connected along its parallel ray, and make sure that they all intersect at these 90-degree moments, it will work out. And if anything begins to look off, if you're not getting 90-degree angles, something went wrong along the way, you can backtrack through it and find the spot where you can recorrect the course of those points, track them back through space, and continue to move the cube around. One thing that can be really important in this drawing technique is to keep track of which view is stable and which is moving. Our plan or top view is always our kind of key viewpoint within these drawings. So the angle we choose to come off of this should remain consistent. That means this begins to set up a trajectory. Now it can flow in a continuous trajectory. That trajectory could position the pieces wherever we want them, depending on how we want to see this object tumble. In this case, I've got my basic isometric setup from before, as we can see, and I've used the auxiliary left front view along with the top view to find here the successive auxiliary isometric view with that 30-30 angle. And the first successive auxiliary doesn't have to be the isometric, it could be anywhere. This is just the one I chose for the demonstration purposes. So what I think I'll do is continue this trajectory going and see if we can't make this cube begin to kind of tumble down the page. Maybe we've already taken it from here and we've tumbled it up to establish this view, kind of get that corner shot, but maybe we can allow it to now fall back down or continue to roll in that direction. We'll see how we go when we get into the drawing. So let's jump in and see what happens. Probably make a lot of use of the adjustable triangle. I have actually rotated my drawing, as you can see here, which might be very helpful as you've set it up and something has started to happen at kind of a strange view relative to this. So my T-square will not line up with the plan anymore like I would have done in part 1, but instead it aligns perfectly with this new axis of projection that I've set up here. And that's just to make it a little bit easier to draw, since most of my work will be happening here for me. And so keep in mind, you can always rotate the drawing around on your work surface and just carefully realign it to your T-square or parallel edge right there so that everything you're working on has a good reference point. And that can sometimes mean I don't have to rely as much on a bunch of different angles for my adjustable triangle, but sometimes we still have to use this one a lot. I'm going to use a mechanical pencil for this just because I find it, a bit faster and easier. You just have to get the one with the nice drafting tip that extends past all your tools. But if you're using the normal drafting lead here, then that will work as well, keeping our lead pointer handy and our cube in view. Okay, why don't we begin with a little bit of time lapse to reestablish some of these lines a little bit more clearly on the page. I'm working through vellum overlays to do a little bit of tracing just to keep consistency with this drawing through different times. Yours will be on the Bristol probably, and in that case everything's already there. Again, you can turn the Bristol however you need. That's effectively what I've done. As a note, so you don't have to do so much adjusting, you can always combine triangles here, and that way I can bring off my 90-degree angles perpendicular to that pretty quickly, rather than always readjusting that adjustable triangle. That takes a lot of time. I'm working here with some recording studio lights on, which are pretty bright and create a generally even surface, but are more light than I would normally work with, and they're not directly overhead like a desk lamp might be. And that actually can make it pretty challenging for me to see what I'm aligning with here through these tools. So keep in mind setting up your workspace, getting a good drafting lamp that you can have control of so you can really see where your tools are will help make things go a little bit faster, as you're not always trying to adjust your view or lean too far around. But you'll get used to it as you work. Now, ideally, we would use our adjustable triangle to figure out these new angles. Since I'm just tracing this to give it a little bit more visual impact on the page, I'm going to draw with my triangle just to connect the dots. We try to avoid this as much as possible, but this really isn't a projection thing. It's mostly just tracing, so I'll go ahead with it for now. It is, however, a really good way to introduce visual air when you have two parallel lines right next to each other. It's much more accurate to rely on the tool, and after drawing one line and looking, not really trusting myself to draw the next one, maybe it is a good idea to jump back over here and find that angle with the adjustable triangle so we can really make sure it's spot on. Okay, I've got my isometric view reestablished and some of the major projection lines starting to show up in there. I'll probably jump back and forth between the different triangles quite a lot, so I'll keep them handy. So if you remember from the first video, what we're doing is in effect trying to see this object from two different angles at the same time, right? To give us a three-dimensional representation similar to the plane oblique. We get this isometric view. And so I have my top view here, and I'm looking at it from this corner, which if we just did it straight as an elevation would give us the kind of front right auxiliary view. And over here I have that left front auxiliary view, right? Just the opposite one coming off at 90 degrees. Keeping that 90-degree relationship is very important. You don't want to rotate that, because if these start at 90 degrees and we bring them back together at 90 degrees, we can maintain our orthographic projection and not cause distortion in the object. So this is really important that from my plan I establish where I'm looking. You could potentially choose any view for this. You just have to maintain the first and second priority relationships. But so this is my first priority, and I'll make some notes on the drawing while I go just to help make it a little bit easier to keep in mind. So this is kind of my number one priority, and the tutorials that have this drawn out for you have some of this in place, so you can refer to that as well. And then I have this view from here, which again is cutting in at that 90 degrees. This has been rotated from my orthographic projection now, so I'm not going to worry about retracing it too much, which has them both coming in at 90 degrees here, right? Or they intersect there at the middle at 90 degrees, 90 degrees. We always want to make sure we're maintaining that clear relationship there. So we'll think of this as our kind of number two projection point. And then we've got this auxiliary left view, which we are bringing out an angle from. In this case, I chose to bring an angle that is relative to this plane. This plane is the triangular cut. And so I am trying to look at the triangular cut and kind of look directly at it because I'm looking perpendicular to that plane. So this becomes kind of our third consideration here. This angle is adjustable. Once we've established this first 90-degree relationship between the first and secondary kind of primary considerations, we can adjust this angle. If we adjust these angles independently, we'll get distortion. If we adjust them together, we'll just get different views. And you can do that. It's a little bit more advanced and complex, and so it'll be turning in two directions at once. Right now, we just want to turn in one direction. I just want to be able to kind of tumble this view down this page. And so if I'm looking at it straight on like that, if I want the cube to rotate up, which means I would see less of the top and more of the front and bottom eventually, then I can rotate this angle like this. And that way I'm starting to see more of the front and eventually could get around to the bottom. I could eventually work my way all the way around. If I wanted it to fall forward, right, because now it kind of looks like it's already tumbling forward from the top view, so maybe that makes sense in the narrative, then I take this view into this plane. Again, this is just a view onto a plane. I start from here and I begin to rotate up. Now, that's going to be a little tricky with this drawing because I'm going to have to like project over the top of stuff or like rotate or all the way around or reflect. So the narrative is a little mistaken here. And I think if I wanted my narrative to be about it falling in that way, coming down the page, I would place these views further apart and I would have to kind of like project and wiggle around and so I could get those right views. So instead, I'm going to have it continuing to roll up so that I start to see towards the bottom corner of the shape. A good way to define your full arc of trajectory or full rolling instance would be to define this first plane, first view. It does not have to start with the isometric, but you can build from your previous drawing or start a full new one. And define my last plane. So these are kind of like keyframes in an animation. We're starting to talk about motion or animate form, and so that's some good things to learn about there. So the keyframe in the animation, I can use my adjustable triangle to define the final plane that I might want to look at. If I want that to be exactly 45 degrees to this object, I would have to go ahead and use my adjustable triangle to figure out where that might be. It's a fun task, right? We can go with this top angle, do all those fine adjustments, leaning our head in. There we go. So now I know exactly where that is, and then I can trust that this is 45 degrees. And if I know this is 90 to that, or parallel to that, and we'll be hitting our 90, this should be our 45 definition. Again, I wanted to use this all the time like this, but it helps me set up my end goal. I don't have enough paper to reach that end plane, but if this is my start plane and this is my end plane, I at least have a sense of what I might create in there. And this is where I could start to use some programming of these angles along adjustable triangle to have even steps. So this puts me at 35 degrees relative to my t-square here. I can go ahead and I'm playing some triangle games. And once you get your adjustable triangle fully open here relative to the drawing, then you can use that to start to calibrate the twist in that angle. Like this won't be able to go the whole way, but as I close this, it'll begin to bring this plane around to this plane. And so I just want a few increments here. And again, I only have a little bit of space here to keep going. So I'm going to draw probably one more view and then the sequence after that is the same. I'll get it started. But let's say I want to tumble 10 degrees, a big enough increment to see something, but not too fast to jump between things and get lost. So I'm at 5 degrees on this triangle and I'll just shift it over to 15. I know eventually it will end at 35, so that can help me out. And now if I bring this in, you can see that establishes a new plane relative to this one, 5 degrees. I think I'm going to go 5 more just to have a little bit more variation. I just want it to be a little more dramatic. Small increments feel more engaging, more animated, a little bit slower movement. Bigger increments do faster movement. So keep that in mind as you plan out your drawing. Okay. This is one of those things where it doesn't really matter where I place this plane. It was really helpful to put it on the cut line there so I could project specific intersections with that plane over to find the hole. But in this case, we're not really addressing the hole, so I might just go ahead and place it on the corner because that seems good a place as any. Now this is my second rotation coming off of the auxiliary. So we'll kind of follow the same process we did here, where I projected straight across. Now I'll need to project straight perpendicular from that plane, right? And as you can see, that's going to place this drawing pretty much right on top of that. This is where this, again, can get pretty complicated. You want to give yourself a little bit of room around the drawing. So this being a very tight relationship is going to be very dense. Now, putting things on top of each other just denotes a much faster degree of rotation, right? They start to overlap and collapse, and that's okay. But if you want them to be more discrete, you either have to, kind of bring things out and rotate it around, or start with a little bit more spacing, right? I could have started with these spaced a little further apart and brought this further over, so I have a little bit more room to maneuver in here. Let's just see what we end up with and enjoy some fun triangle manipulation as we try to figure out how do we draw from this specific angle consistently. That you might want to fix your T-square to your table, just with a little bit of tape or something every once in a while so it doesn't move around too much, so you can really just do a lot of drawing by moving these two items more quickly. In fact, I'm going to do that just for a minute because I think I'm going to have to draw a lot of projection lines right here, and it's going to take a bit of time. The one thing you'll want to keep in mind is that we are trying to create the same relationship as this, right? Which means that these two rays have to intersect at 90 degrees. So whatever comes off of this is going to quickly have to turn to hit this at 90 degrees. I could just bring whatever corner of the object that I start with, so if we just start with this one, all the way over to the first projection line, and then use that as my hinge to create the little pie wedge there. I'm going to do it a little bit sooner. It doesn't particularly matter where, but it might be helpful to predefine it. So I'm going to draw a few of my projection rays from key points and then choose where to have it happen. And don't forget your back corner. Oh, unfortunately, I can't quite reach it, and that might be a case where we have to get a little creative now and then to bring in a multi-tool setup, but this gets very complex to hold everything in place, so try to only use it for one or two lines, not a lot of parallel work, not a consistent amount of work, but you can do it. So this edge is defining with this edge, and this edge is defining with this edge, and then I can bring that over. But I'll probably only do that once because that's very cumbersome to work with. Okay, so I'm just bringing these key points, the back corners, the front corners, and the cut corners over in this direction so that I can intersect them with my top view's information. And I'll have to choose a hinge point, so I'll need my T-square to be free again. Come over. And again, it's anywhere in here, technically, wherever you want. You could go even through the object. I could go way over here, hit it as a mirror, and then hinge back. That is fine. Or hinge forward. That is fine. Why don't we hinge forward just from a place that's kind of easy to keep track of. So we'll do it based on this point back here. So we just do a full arc hinge and don't have to do anything crazy. And we'll do it just a little bit over from this line. Measure if you want, but since we don't have to measure, we'll just draw a line, and that is where I want to get. I want to get from this to this in a little pie wedge. So I can bring this in, and again, from my back corner where it intersects that line, I now have a little wedge starting, and I can bring my compass in. Might as well go out to the farthest edge first, just to define the space we're working in. Now this, when it first hits just at that tangent, is 90 degrees, and when it hits this new line I've drawn is 90 degrees. So from here, it can start going that direction. And I'll do all the other lines, just get them transferred over quickly, so we can start drawing the new view. So now I brought those all over, I can realign to my nice 90-degree drawing place here and just use my triangle to quickly extend them out into space. Remembering that I established this line, not this one, as my hinge, but that's up to you. And this drawing is going to kind of land in the same boundary as this one, so I really just need to bring them over to that edge. Now, it never hurts to double check and make sure we always use the same 90-degree place. It looks like I did it okay right there. That's going to be a tough spot because those points basically land on top of each other, but one's in back, one's in front, and so we just won't really see that much difference in this bottom angle. And so it looks like we're okay. Let's start to bring down some of these projection lines and see where they intersect. So one of the things that can be really easy to mix up in these drawings is front and back, because you're kind of rotating in two directions in space at the same time. And again, we can go back to our setup to make sure we're keeping track of where we're at. We're looking from this side primarily, and then we're going to look from this side as our secondary movement, that successive auxiliary condition. And so I can see, okay, from this plane, I will still see this bottom corner, I will still see this back corner, I will still see all this front stuff. And it's only until we kind of reach around to here, at some point, once we get straight on with this, we won't see the back corner anymore, we would just have an elevation. And when we get to there, we're going to see only these two sides. So use the second elevation view to help you think about what will be showing when you get to like the depth of the drawing. Let's see, what do we have here? We have our bottom corner point here. Again, we can double check that is this point here that comes down through the middle to over here and comes around here. So if it helps, on a piece of trace paper for the first one or two, you can just kind of work through this, and that's B and F. So I guess that is point F, as we see right up above there as well. And might help to find the boundary points. So let's see if we can find G and E. Well, they come out this way and down, come over and down. And if we go back here, E is here and G is behind it, since they come from the same place across. So we just find those coming out in this direction. Oops, I didn't bring them over. We'll have to come back and get our points. And it's easy to make those little mistakes. And we just have to come back here, get our 90. So hopefully that adjustable triangle we can keep in one location for a while, so we don't have to constantly readjust it. But let's see. Got that there. Just coming through till our rotation line, that start of the hinge. And we gotta get our triangle, or our compass back in play so we can do the next part of the hinge. It's pretty common to forget a few lines. There's a lot of points, and as you start to keep track of those points, maybe with a label, and start connecting the dots, we quickly find, oops, I missed one. No big deal. We just come back in and add it to our place, follow the system, track it over, and now I can identify where those 2 points are that are labeled E here and G. And similarly, C and A would be a good one to do. So that's this point here. Again, I forgot to bring that one over because I was only focusing on the front edges. So we go back to our tools, back into here. And while it may feel like you want to add all of the details at one time to the drawing, that's pretty challenging and takes a lot of time to track them all at once without setting up the basic premise. So my suggestion is to get the box in, get several boxes in, and then come back and track what details you want to show. The goal here not being to draw cubes, but to draw a system of projection that moves geometry around the page. Okay, so we brought, we needed A and C, and that comes down this direction to here, hinges around to here at 90 degrees, again 90 degrees, comes across and hits these 2 edges there and there. And so that would be A and C. So now I've started to establish a decent amount of the bottom part of this cube, and maybe I'll just do the top back corner D here, since I have that in place and it's easy to add. So that one I've already brought over, rotated around and brought it here, and it's gonna be right in there. This gets a bit fun, since I'm not gonna draw all the details and I brought most of my lines over now, right? I make sure I have every single point addressed. I might have to realign some things with my adjustable triangle to draw the cube. This angle for the isometric that was so nicely 30 degrees will no longer be 30. It's going to become something else for us. So why don't we start blocking that in? I'll use my heavier pencil just so we can see this new drawing emerging. All right, connecting the same dots, C and G, A and E, F to G, F to E, and so on. but I've got the general shape of the box coming in there. And now I have to find that triangle, which will no longer be the true shape of the triangle, but just some rotated view of it. So we can track some of those over. We've already found B3 at the bottom, so we need B1 and 2, and those come around here and intersect with the outer corner there and there. And that is verified by our projection here as it comes to that point. So there we have the top shape. Again, slightly more squished as we're rotating up the face of the object. And we just need to connect a few dots for the triangle. Again, I would want to set my adjustable triangle to these. Actually, I don't have any more lines to draw, so there's no reason not to figure it out accurately. So let's just bring in the triangle. And if it's the first time going through this, it is very helpful that I'm working on this symmetrical axis, so my angles work on both sides. But if I had chosen any other rotational dial here, so long as these stay perpendicular, I can do this in any direction I want to show maybe different things on my cube arrangement. It can be then very complicated because we have to like double our angles here, and you kind of want to think out where you're working. So you would work all on one side with those angles, then switch to the other before you switch the angle of the adjustable, so you're not spending all your time adjusting the triangle. But hopefully now we can start to see this next rotation. Let's step back and kind of review how that all is set up. We start with the initial view, the top view, and we project it off an auxiliary view. And now we're looking for the secondary, tertiary, and other successive auxiliary views. So this relationship we've set up here defines how we will project this direction. So we should maybe change this to number 1 and number 2. And we must keep that at 90 degrees. And then we can place this wherever we want. I chose to rotate it and bring it down. It could have continued off on this path. It could go wherever it is. And that's something you can plan out, right? If I kept going on this path, I would have a lot more room to maneuver in here and space things out. Since I'm on this path, things are much tighter. It's compressing the views much faster. I just don't have a lot of room to maneuver. And then the first successive auxiliary, I chose a plane related in this case to something on my object because I'm seeing straight along that cut. So it just became a plane in space, and take that plane and project this way to draw the true triangle shape. Then I took that same plane and I rotated it so I'd see a little more of the front and a little less of the top, and that triangle shape is now no longer a true shape, it's just a triangle in space. And I project that over, bring it around to the 90 degrees, and intersect it with all the same points at 90 degrees. The next one I can do, maybe it's going to be here, same thing. I'll place that plane in space, and that's the angle I project everything to that plane, wherever I want to place it over here, if I kept just rotating from here, right? And then I rotate that around and bring it over 90 degrees. And I can do it again and again and again until I hit my end goal place here. So why don't I set up a few of my rotation goals to see how far I can get, and see if I can draw a few more of these before I run out of page space. This line is not strictly necessary, I just use it to help me visualize, so I'll make it in a very light tone, coming from this same point, so I kind of create some fanning arcs. But what's more important is the line where I'm going to hinge around, which is parallel to that, and just over based, why not, on this same hinge location, and let's see what happens. And as you can see, this area is going to get very dense. It might help to use some layers of trace paper to plan things out, but I think if you just draw through it and you draw very lightly and you track kind of one point at a time to one rotational edge at a time, it'll be okay. So another thing you might be becoming aware of is that this can take quite a bit of time. And so take it one step at a time and do as much as you can. to rotate one cube through space on its own trajectory. You might take your 3 cubes and break each one up into its own initial 90-degree relationship so that one can fall this way, another could fall off over this direction, another could fall off over that direction and tumble through space to create a very dynamic drawing that starts to fill the page. And you only need maybe 3 to 5 tumbles in any one direction to give a sense of motion. So start there and see what you come up with. And one way you can keep track of these is that they're always the ones that will have no extension lines to them to begin with. So if it does help, right, we can always do one line at a time. So I can just bring over this. I know it intersects. Let's see what we're doing, right? F is going to be that front corner. It comes from up there. I know it intersects with this middle line, so I can just bring it to there to keep the clutter down if I want. And so that'll be the point. You don't need to make these dots. I'm just making them for visual reference here as we can see and talk together, right? Or I could do very light notation there. Same here, I'm bringing over E, which has to go all the way across, so make sure we got enough space. And that's going to intersect there and there. And so now we found our angle that we can readjust our triangle to. Hopefully we've gotten all those across, right? And we'll bring that in and try to find that very low incident angle there. Just barely seeing the top edge, almost coming around to the bottom edge of this object. And that looks about right. So again, we can see this angle kind of gradually flattening, and that makes sense as we're moving our way around back towards almost just the auxiliary elevation, and then we'll continue to rotate around to the bottom. I made a little mistake there, and that A point should have been up there, so I was connecting the wrong dots. Can't really erase it, so we'll just have to work our way through it. See if we can't clean it up a little bit. And there we go. Now I've got the consistent corners making the 1, 2, 3, 4, 5 sided shape. 1, 2, 3, 4, 5 sided shape. I have a little mistake in there. That's okay. We can just do our triangle now and clean it up. Again, you can kind of see the more traditional isometric, slightly rotated, slightly more rotated. And if I do another view, right, they're going to start to stack up on top of each other. The next view might be the front elevation of that front corner that you've drawn before, just by projecting straight off of there. In effect, we would get to that. Maybe we can try to bring this one around and see what we end up with. And from time to time, I mean, I like using this point, but at some point I'm going to have to readjust because there's no way to get that there. So again, I can pick anywhere to kind of do my rotations. If you're ever wondering what that thing was, it's so you can draw bigger arcs, and it gives you kind of a double extension. You can loosen this to move it in and out, but I've gotten myself into a place where I need a much wider arc here. So I can do that. And again, it might go off my page a little bit. You can't see what I'm drawing down there, but it helps me track the points even if I will draw the drawing off my page for the composition. This drawing is going to end up in this space down here, and it's going to be more of a view up underneath the object, so to see that we can rotate anywhere. We'll just bring these across. Again, the one you can't see me drawing down here is kind of this back corner, which is now in view, so I do need to track it. And we'll draw to it even if we can't see it in the composition. But it would be on this same central spine that I've been tracking. And so let's see what we can find here. We have F, that's a nice easy one because it's right on the center. So we still have F. This one labeled as H, you won't be able to see because it's down off my page, but it's there. E here, which is again these outer corners. Oops, didn't quite come down far enough. There we go. And we do see the bottom cut of the triangle, so B3 that comes around, and that is going to be there. See the top edge there of the triangle, but we won't see the top of the box. You just see the edge of the cut. And so that's coming down and around to here. And we won't see these edges directly, but we might need to find them so that we can connect them here. So I probably need to bring that on back around. So I made a little mistake and I drew to my rotation edge, my hinge edge, instead of to my object edge when I set up my angle. So I'll have again, a little bit of an error there, but I can come back later. That's in a fairly clean place and fix it if I need to. And now my diamond is starting to line up correctly here. We can see that we get that diamond shape, same diamond shape that's up here, rotated all the way now from this point to this point. So a full 90-degree rotation around the object from one corner to another. And we're just barely seeing a little bit of that angle of the cutoff there. Many of these techniques build up their complexity very fast, and that can be a challenge to keep track of all the points. But this is partly why we're learning this. It's a way of developing an acuity of seeing and tracking points in space so that when we enter into the digital realm, we're able to keep a good visual acuity of what's going on, or be able to evaluate things that the computers generate for us so that we can enter into them and have some agency in the design process. It's also just a good exercise for spatial thinking and the tracking of geometry to be able to know that without this object handy, if you're designing something, you can track any position of it from just 2 views, maybe 3, right? If we need to know a little more information, but in general, if we have enough information from 2 views, we can track everything we need to know about the object and establish its own new projection system at any angle relative to how we want to see it. And that can help us communicate our ideas to others, or even just explore what might take place as geometry works its way around a page and we have to resolve new collisions and intersections and overlaps. And that's where the next half of the semester is going to take us, as we dig a little deeper into how we generate ideas with these drawings beyond representing things we can see. Let's take one final recap of what's going on here so you can use it to help with your drawings for this week's assignment. So to begin, any successive auxiliary drawing, whether that's from the isometric or any new angle, and I encourage you to try some new ones after you have a sense of how the isometric works. You'll establish a top view or a primary view. It could start from any elevation, but let's just say start from the top view, and you'll take and project an angle that you want to look at. So here we have our first priority angle. In this case, I chose it based on the fact that it would cut straight through this triangle of my cube so that it would be an opportunity to look at that triangle as a plane. But if I chose any other angle, it would work. So whatever that first angle is, establishes the second angle here, which must be at a 90-degree relationship to that angle. So this is kind of our like compass point, and we can dial it in, but everything turns together. So as long as that maintains a 90-degree angle, we can draw anything we want out here relative to that position. And what we're defining there is two angles of view onto the same object that we're going to bring back together and collide to get that third or successive auxiliary view angle. So what's happening here is I've brought my top view information down and around as if I was going to draw this elevation, right? If I was just going to draw the right front auxiliary elevation, I'm just bringing that around and I rotate it or hinge to have it flow straight down my page. This could have continued this way. This could go over here. This could go anywhere you want to help you work with a composition, not just follow my kind of smushed up drawing here. And then when I came over to this view, what I want to do is take the view I'm having onto this top and combine it with some view onto this side view. My first one that I chose for the isometric was straight through that plane of the triangular cut, because that would allow me to draw that view of the triangle as if it was actual dimension, and I could measure it. All of these sides are the true length sides of that triangle, everything else here being distorted because of the isometric angle. So that first auxiliary projection brought the plan information around for an elevation, brought the elevation information over, and made a kind of third or successive auxiliary elevation. Each successive auxiliary elevation, I just took that same plane in space and rotated it relative to some point. And that's just establishing a new view plane. So from that moment, I'm looking onto that object from that plane, bringing it over and hinging it to collide at 90 degrees with the same top view elevation. So you want to keep this stable for like something like this, where it's a consistent rotation, because if you rotate this, you have to rotate the whole system and you're going to end up drawing the same view over and over again. But what you can do is take this and you could put it off to the side, and you could do a series out over here if you want to have this rotating out that direction, and this coming down here. Like I said, it got a little crowded in here, so maybe I could bring that further this way so I'd have more room to maneuver my hinges here. And so I did a couple of angles there of just sequential 15-degree rotations. This one, again, bringing it around, hinging, and making this almost straight on view. But still, everything is parallel. So this angle and this angle are parallel. This and this are parallel. That and that are parallel. That and that are parallel. Any angles that are related to the cube remain parallel within this context. And there's always a perpendicular intersection of the two views at the hinge line that you choose. The last one, I just went for a much longer rotation. So I got kind of all the way around down to this view, looking at the bottom of the cube. Right, just kind of like that. Or I can just see a little tiny bit of that triangle, mostly the bottom, and then the right and the left sides. Can't see any top anymore, can't see the back too. So I went from here over to here just by projecting these two views together from different angles. So that is a way to kind of think through what you want to create and what you can express, and be very kind of programmatic about how you do it to introduce successive kind of movement-based rotations or animations. So this one came around. I just did a quick rotate around to put it a little further down the page so we could look at it in a little bit cleaner context. So hopefully that starts to make sense and give you direction to go. Take it one point at a time, track your way around, get used to the tools, set up your lighting, keep your compass and your pencil sharp, and in no time, you'll get the hang of it and you'll start to draw really complex things. And if they get dense, they overlap, or they get kind of a little bit chaotic, draw through it and find something new. All right, have fun. We'll see you next week.